Today we are going to discuss the molecular term symbol lecture 4. This is the last lecture on molecular term symbol. In this lecture we will discuss about the heteronuclear diatomic molecules like CO, Cn-, NO+, and N2. These molecules will be discussed in this lecture, and we will also discuss about the terms for equivalent electrons and terms for non-equivalent electrons. Term symbol of heteronuclear diatomics. For heteronuclear diatomics, the term symbol does not include the G or U part, for there is not inversion center in the molecule. These are the homonuclear diatomic and heteronuclear diatomic molecular orbital diagram. So in homonuclear diatomic, both the orbitals of the same atom are of equal energy. So this is the bonding and this is the anti-bonding. In heteronuclear diatomic molecules, one atom, the electronegative atom, and another electron will be electropositive. So there is be lower energy in electronegative atom and higher energy of electropositive atom. So this will be the bonding and this will be the bonding. The only difference is that of the energy level. This is the MO diagram for diatomic CO. So this is the MO diagram. So this is the carbon atom. So this is 2s, 2 electrons, 2p, 2 electrons. Here 2s, 2 electrons, and 2p, 4 electrons. So these are the molecular orbitals formed, and we represent these by sigma 1, sigma 2, pi, sigma 3, pi star, and sigma 4. So this is the MO diagram for CO. If we take the excited state of this CO, means this electron will be promoted here, then one electron will be in sigma and one electron will be in pi. So this is the case of electrons non-equivalent because they are of different energy. Now the term symbol of CO, Cn, NO+ or N2. The heteronuclear diatomic ions, just like cyanide ion and natrosium ion, are also isoelectric with nitrogen and carbon monoxide. The only difference between the MO diagram are the relative energies of the orbitals. All the molecules have a closed shell configuration. Its ground state is totally symmetrical singlet, so the term symbol will be 1 sigma plus, since the only possible values of S and lambda are 0 and 0. If we want to know the term symbol in CO in excited state, it means the one electron will be promoted from sigma to pi. Suppose a CO molecule is in the excited state shown above. In order to know the term symbol of this state, a direct product of the level is required. For the two MOs with unpaired electrons, the multiplication is such that pi and multiplied by sigma plus is equal to pi. According to Pauli's exclusion rule, these two unpaired electrons can never share the same set of quantum numbers. Therefore, this spin degeneracy S can reach its maximum 3, that the resulting term symbol is 1 pi and 3 pi. Here is the electron is paired and here the electrons is unpaired. Terms for equivalent electrons. If this is the sigma 1, this is the sigma 2. If the two electrons are in sigma of equal energy, then the term symbol will be there. Here is pi 1, pi 2. If the two electrons are present in 2 pi orbitals having the same energy, this is the term symbols, and this delta is here given, but we have not discussed these in our discussion. Terms for electrons not equivalent. If the electrons are present in not equivalent orbitals, that is of different energies, just like sigma and sigma, it means one electron is present in one sigma, another electron is present in another sigma, but of different energy, then the term symbol will be there. If one electron is sigma, one electron is pi, then the term symbol will be there. Here also we have discussed that delta is given, but we have not discussed the our chapter in delta. The numbers in brackets indicate how many of these states exist. The subscript R denotes regular or normal multiplets. Terms for electrons not equivalent. It means when the electrons are not equivalent, the energy is different. Just like if there is 3 sigma orbitals having different energy levels, then the term symbols will be there. 2 sigma, 1 pi, then the term symbol will be this. 2 sigma, 1 delta will be this. So this is the table showing the term symbols for non-equivalent electrons. Here delta is also given, but we have not discussed in our topic. The number in the brackets, these indicate how many of these states exist, and the subscripts are like this, denote regular, normal, multiplets. This is the selection rule for electronic transitions. We have discussed the selection rule for in atomic term symbol. Here this is the selection rule for molecular term symbols. Allowed transitions. Delta lambda is equal to 0 or plus minus 1. This is the allowed transitions. Here in the atomic term symbol, just like S, P, D, F, there is not allowed transitions from S to S and P to P, but here if the lambda, delta lambda is equal to 0 or plus minus 1, then the transitions will be allowed. Delta S is equal to 0. It means transitions can be take place only when the spin multiplicity is the same. Here sigma to sigma will be allowed, sigma to pi will be allowed, and delta to pi will be allowed. Here singlet will be allowed, triplet will be allowed. In the symmetry, plus is allowed, means sigma plus the allowed transitions, and here minus is allowed, so sigma minus is allowed, and this is G to U is allowed transitions, that is sigma plus G to sigma plus U is allowed, and delta G to pi U is also allowed. If this is not allowed or forbidden, is from G to G or U to G will be the forbidden transition.